Dear students, you have learnt about the logarithmic differentiation in the earlier sessions, and we have worked out some problems. So, if the function is is in the form fx to the power gx, that means the base as well as the index are both functions of x. No, we have to take the logarithm, then differentiate according to the way the function is given. Maybe most of the cases we apply the product rule, sometimes we may have to apply the quotient rule. Or if the given function is a very much complicated, having numerator, denominator in the form of a rational function, no, then it is better to take the logarithm and differentiate. That makes the differentiation easier. We have worked out some problems, and today's session also I am going to work out a few more problems and complete this particular topic. Now, the first problem is y is equal to x plus 1 by x whole to the power x plus x to the power x plus 1 by x. X plus 1 by x. Now, sometimes even in the question paper, this y may not be given. They may simply give this right hand side part, they may ask you differentiate this with respect to x. Then better you take it as y. If it is y is given already, well and good, otherwise you take let y be equal to that one if it is not given in the question paper. So, let y be equal to the given function. See, in this is the sum of two functions. We have done in the earlier session that when it is given as the sum or the difference of the functions, directly you can't take the logarithm. So, what you have to do? You have to take individually u and v, individual function you have to apply the logarithmic differentiation procedure. Then finally, you have to substitute in the given function in the way where we have written dy by dx and du by dx, etc. So, usually we take them as u and v. So, one by one I take this as u and that as v, and then finally arrive at the value of dy by dx. So, let me write like this, let u be equal to x plus 1 by x whole to the power x. The procedure is same, the same the calculation takes place in the same number of steps also, but here we have to take them separately. But for individual terms, so we have to apply the logarithmic differentiation procedure. Let u be equal to x plus 1 by x whole to the power x. Then what's the next step? You take logarithm. You take logarithm. Then here u becomes log u. As you know that something raised to the power x, log of m to the power n would be n into log n. So, directly I am writing it is x into log of x plus 1 by x. You just keep it as it is. You need not take the LCM and apply the second law of logarithm like that. You can keep it as it is, or you can apply the second law logarithm. Still you can simplify this and then you can differentiate. Both methods will have the same number of steps, so better to keep it as it is. But be careful when you do the differentiation because it is a composite function. So, log u is equal to x into log of x plus 1 by x. Now, differentiate with respect to x. Differentiate with respect to x. So, as usual, the left hand side is log u becomes 1 by u and u becomes du by dx. Now, here we are applying the product rule. First function x into the derivative of the second. Log of something is 1 over that something x plus 1 by x, because we know the derivative of log x is 1 by x. Now, because itself is a function of x, write inside the bracket, for 1 x it is 1, for 1 by x it is minus 1 by x square. So, first function into the derivative of the second, this being a composite function, I am applying the chain rule. Log of x plus 1 by x is 1 over x plus 1 by x. If you want, you can write the bracket also, into differentiate this one. So, it is 1 minus 1 by x square plus the second function log of x plus 1 by x into derivative of x is 1 of this one. So, this is the first step. Now, to get the value, it is 1 by u into du by dx on the left hand side. Here I do some simplification, x into 1 divided by here x plus 1 by x I am having, look here, x plus 1 by x. So, you have to take the LCM and simplify. So, in the denominator itself, LCM would be x here, x into x, it is x square plus 1 here, okay, into, again in this other term also you have to take the LCM, that would be x square is the LCM there and it is x square minus 1 plus second one it is log of x plus 1 by x, okay. Now, only in the first term you can simplify, some term is getting cancelled, that is this x being the denominator of the denominator goes to the numerator. This becomes x divided by x square plus 1 and here it is x square minus 1 divided by x square. This I am writing as it is. Look here, x into x, x square and x square, no, they get cancelled. So, this would be logarithm of x plus 1 by x, no change in this one. Therefore, now take u to the right hand side, that is du by dx would be u. What is u? You have to write here because u and we have taken for our convenience to simplify the function. Therefore, we can to do the differentiation, we cannot write u and v in the final answer. Now, into write this one, it is x square minus 1 over x square plus 1 plus logarithm of x plus 1 by x. Now, take it as result 1. So, what we have done? We have taken the first part of the function to be u and we have applied the logarithmic differentiation procedure. We have taken logarithm, then applying the law of the logarithm we get this one. Then we have differentiated with respect to x here and because it is a composite function we applied the chain rule, we have done the simplification and finally taking u to the right hand side, what is u you have to write, this is the derivative of the first part of the function. Now, let me take the second part, okay. Now, how do you take the second part here? When you have taken u as the first one, let me take it as v. Let v be equal to x to the power x plus 1 by x, x to the power x plus 1 by x. Now, here also you take logarithms. The procedure is same, okay, whatever may be the function. Take logarithms, that is log of v on the left hand side would be equal to, look here, x is the base, this is the index. So, whole of the index, no, it becomes the coefficient, isn't it? So, it is x plus 1 by x into log of the base. Log of, here also no need to simplify, you can keep it as it is. Now, log v on the left hand side would be the index x plus 1 by log m to the power n formula, n into log m. So, here again next you write differentiate with respect to x, that is the next instruction. So, log v as usual becomes 1 by v and for v it is dv by dx. Look here, again there is a product here, apply the product rule. First function x plus 1 by x into derivative of the second, that is log x has the derivative 1 by x. Now, both of them are simple functions in this case, plus second function, that is log x into derivative of the first. For x it is 1, for 1 by x it is minus 1 by x square. Now, here if you want you can multiply by these two terms here, that is 1 by v into dv by dx would be equal to, when you multiply x into 1 by x is x and x they get cancelled 1 and 1 by x into 1 by x becomes 1 by x square plus you write it as it is log x into 1 minus 1 by x square. Now, this is 1 by v into dv by dx. So, what you have to do, this v has to be taken to the right hand side, to the numerator of the right hand side. Therefore, I can write it as dv by dx. Therefore, write it as dv by dx is equal to, shifting v to the right hand side, what is v you have to write, x to the power x plus 1 by x into, write all of them in the bracket, 1 plus 1 by x square plus log x into 1 minus 1 by x square, close the bracket, take it as result 2. So, these are quite lengthy problems. Okay. Now, because both of them are little bit complicated functions, and when you apply the logarithmic differentiation, we have to take logarithm, then differentiate with respect to x, and in such problems simplification will not be possible because we will be having too many functions, there will not be any common factor or any such thing. So, the answer is usually a very lengthy answer. So, we have done here, we have got the derivative of two parts of the function. Now, you write here. So, this was the given function, y was equal to this one. So, the given function, write like this, the given function after making the substitution, y is equal to u plus v. Given function y is equal to u plus v. Now, differentiate with respect to x. Therefore, we have dy by dx would be equal to du by dx plus dv by dx. Okay. So, as soon as we make the substitution, this becomes u, this becomes v. On differentiation, dy by dx would be du by dx plus dv by dx. Look, from the first and the second result, we have got the values of du by dx as well as dv by dx. Now, substitute here and write all the terms, that is, you write dy by dx would be equal to, first we take the first result because it is du by dx, that is x plus 1 by x whole to the power x into x square minus 1 over x square plus 1 plus log of x plus 1 by x. Okay, close the bracket. Now, this is the derivative of the first part of the function, in other words du by dx. Next, I go to the second part. What is the second part? X to the power x plus 1 by x into, write that one, 1 plus 1 by x square plus log x into 1 minus 1 by x square, 1 minus 1 by x square. So, let me rub this one. Now, close the bracket. Now, you write from 1 and 2. That is why I had given some numbers so that we can refer to that one. Now, this is the derivative of the given function. You observe it is quite a lengthy derivative we are having because both the parts of the function they are quite complicated function. So, dy by dx would be, this is du by dx, that is dv by dx. So, from 1 and 2 the numbers, how did you get this one? That is for reference. From one and the first and the second result, I have got the derivatives of the two parts of the function. So, this is the procedure we adopt. Of course, same type of problem we did in the previous sessions also, but this problem is it contains more steps here because both the parts of the function are little bit complicated functions. Now, let me move on to another problem. In this one, we had the algebraic function x plus 1 by x to the power x and the reverse of that one. In the next problem, I am having the trigonometric functions. And of course, it's let me consider the problem. Y is equal to x into cos x whole to the power x plus x into sin x whole to the power 1 by x. Now, these are the two terms of the given function. So, in the previous one, we had here some number raised to the power x here and x raised to that number. So, the same numbers were present. Once it was in the base position, other time it was in the index position. Now, it is the different, it is containing the trigonometric functions, a product of x also, x cos x raised to the power x, x sin x raised to the power 1 by x. The procedure is same whenever you are having either addition or subtraction, sum or the difference of two functions, don't ever take the logarithm. Always you have to take them as u and v. Separately we take the logarithm. As it is, you can never take the logarithm because there is no rule to find the logarithm of the sum of the two functions. For product and quotients we are having. Now as usual, let me take them one by one. Let u be equal to x cos x whole to the power x. X cos x whole to the power x. Now because it is of the form some function raised to some other function, take logarithms. Take logarithm. Then left hand side is log of u always. Right hand side log of x cos x whole to the power x. So this x being the index becomes the coefficient x into log of x into cos x. This x I am writing here, or you can write one more step also. Log of m to the power n is n into log of m. Here look at the number here inside the bracket. It is in the form of log of m into n. Either you can keep it as it is and then apply when you differentiate. No, you can apply the the chain rule here because it is a composite function, or else you can apply the law of the logarithm also. It is of the form log m into n, log m plus log n. Both ways you get the same answer. So instead of having a product, I can write this as x into, this would be outside, it is log x plus log of cos of x. Log of cos of x. This is log u. You would get the same answer even if you had kept it like this only. Now differentiate with respect to x. So differentiate with respect to x. With respect to x. So left hand side the usual one, 1 by u into du by dx. Always it will be of that form, either 1 by v, 1 by u or 1 by y. Right hand side, it is a product of two functions, x into log x plus log of cos x. Let us differentiate applying the product rule. First function x into derivative of the second function. Log x means it is 1 by x plus log of cos x. It is a simple function. It is a composite function. Log of cos x means 1 by cos x. For cos x, the derivative is minus sin x. Close the bracket. So first function into derivative the second. Log x would become 1 by x. Log of cos x is 1 by cos x. For cos x it is minus sin x plus second function. What is the second function? Write this one. Log x plus log of cos x into derivative of x. It's a very simple function whose derivative is 1. Correct? Now you can multiply and write it like this. 1 by u into du by dx is multiply only these two terms by x. X into 1 by x. X and x they get cancelled. We get 1 here. And plus of minus, look here, x into sin x by cos x, it is tan x, isn't it? So only these two have to be multiplied by x, and other two terms now write them. Multiplied by 1 means they can be written as it is, log x log of cos x. Okay. Now it is 1 by u into du by dx equal to 1 minus x tan x plus log of cos x. Now u has to be taken to the right hand side. Write what is u. Therefore du by dx would be equal to, when you take u to the right hand side, what is u we write? It is x cos x whole to the power x into, write all of them in the bracket, 1 minus x tan x, 1 minus x tan x plus log x plus log of cos x. Now take it as result 1. So this is the derivative of the first part of the problem. So then again the same calculation we have to do for the second term also, or the second part of the function also. Now Let me consider the second part here. Now, what is the second part? It is also containing a product x into sin x like that. Let v be equal to x into sin x whole to the power 1 by x, whole to the power 1 by x. So, what we have to do? As usual, take logarithm. Take logarithms. Next, log v left hand side. Here x into sin x whole to the power 1 by x. So, index is 1 by x. When you take the logarithm, log m to the power n. So, this is n. The index will become the coefficient, that is 1 by n into log m, 1 by x into log of x into sin x, x into sin x. Now, again, as in the previous part, this is a product. So, I can apply the product rule. That the product rule means first law of logarithm, I mean log of m into n can be written as log m plus log n. See, in this one, see, in all the earlier problems we had the index to be only one term, like here x. Only in this one I am having 1 by x. So, this x can be kept as it is for the differentiation part, or x can be taken to the denominator. If you have kept it 1 by x as it is, take it as first function, we have to apply the product rule. When you take x to the denominator position, you have to apply the quotient rule. Again, both rules we get the same answer. Now, let me apply this logarithmic rule here. It becomes log of x plus log of sin x. I think it is little bit better write like this, divided by x. So, I have applied the first law of logarithm and written the terms in the numerator. This x 1 by x, x being in the denominator position, I have not written this as a product, I am writing that as a quotient. So, when you differentiate, which rule you have to apply? The quotient rule. What does the quotient rule say? See, product rule we have applied in almost all the problems. Here I am applying the quotient rule. What does the quotient rule say? The denominator into the derivative of the numerator plus the numerator into the derivative of the denominator, denominator into the derivative of the numerator minus the numerator into the derivative of the denominator, whole thing divided by the square of the denominator, that is v into u dash minus u into v dash divided by v square. Or always remember, I have told you repeatedly in the earlier sessions, denominator into derivative of the numerator minus the numerator into the derivative of the denominator divided by the square of the denominator. So, let me differentiate with respect to x. It is 1 by v into dv by dx. So, let me apply the quotient rule. What is the denominator here? X into differentiate the numerator. Log x has the derivative 1 by x plus log of sin x. Here it is a composite function. First we apply log. Log of anything is 1 over something, that is 1 by sin x. For sin x it is cos x. Close the bracket. Denominator into derivative of the numerator minus the numerator. Write the numerator. Log x plus log of sin x. Log of sin x. Now, this is the numerator into derivative of the denominator. Denominator is x, whose derivative is 1. Whole thing divided by square of the denominator. Even if you had kept it as a product also, we would get the same term. There will not be any change in that one. Now, it is 1 by v into dv by dx would be equal to, see, let me multiply these terms, then it is a little bit better. X into 1 by x is 1 because x get cancelled, plus cos x by sin x, as you know, is cot x into x, that is x into cot x. Now, both these should be multiplied by the minus sign. It is minus log x minus log of sin x. Log of sin x, whole thing divided by square of this number, that is x square. Now, this v should be taken to the right hand side. Now, I am writing here dv by dx therefore equal to v. What is v here? Write that value, do not write v here. X sin x whole to the power 1 by x into the entire thing should be written, whole of this one, that is 1 plus x cot x minus log x minus log of sin x whole thing divided by x square. Now, this is the second part. So, du by dx is already there, dv by dx I have calculated. Now, these are the two parts of the given function whose derivatives we have calculated. Now, let us come to the conclusion part here. Now, the function, now you have to write that one, the function y can be written like this, it is u plus v. So, after taking them as u and v, y becomes u plus v. Therefore, when you differentiate with respect to x, it is du by dx, dy by dx equal to du by dx plus dv by dx. That is why first we calculate both of them, that is du by dx and dv by dx, better you calculate them, then finally you can express here. Now, take the results 1 and 2 which give us the derivatives of the both the parts of the function and write it here. What is du by dx here? X cos x whole to the power x into 1 minus x tan x plus log x plus log of cos x. Okay, cos x. Close the bracket. Plus, write the second part, x into sin x to the power 1 by x into 1 plus x cot x minus log x minus log of sin x whole thing divided by x square. Now, here quote, how did you get that one? Always you write it as from 1 and 2. Okay. So, this is the answer. You can see how lengthy the answer is, and you can never do any simplification because we will be having two different functions and their derivatives will be entirely different. So, in such problems, especially when there are two terms in the given function, where we take the logarithm individually and differentiate individually, then finally write, it is quite a lengthy answer, but all of them should be written. Then only you get the full marks for that one. First you have to take them as u and v, and then apply the logarithmic differentiation procedure, and then you differentiate both of them individually and get the values of du by dx as well as dv by dx. Then you write this one. Then y becomes u plus v or u minus v depending upon the sign given in the problem. Then du by dx plus dv by dx, whichever already have been calculated, finally you write them, that becomes the derivative of the function. Now, all such problems, especially when we are having two functions like this, added or subtracted, it is the same procedure we are repeatedly applying. The procedures, no? The same logarithmic differentiation procedure which would be applied repeatedly for both the terms. The procedure would be same, but we have to do the thing again and again. Now, we move on to another problem, that is y is equal to x to the power sin x, x to the power sin x plus sin x whole to the power cos x, sin x whole to the power cos x. Now, this is the procedure, same procedure we are adopting for this problem also, because you observe that the function here also contains two terms and both of them like this, some function raised to another function, same thing here, it is involving algebraic as well as trigonometric functions. So, as it is, because in between we are having the plus sign, As it is, we cannot take the logarithm. As usual, we take it to two parts here. First one as u, second one as v, then finally we arrive at the result. So, let me start with the same procedure. Let u be equal to x to the power sin x, x to the power sin x. Now, take logarithms. Take logarithms. It is a little bit simpler than the earlier two problems because there the function itself had contained product and raised to some power. It is comparatively simpler problem. So, take logarithm means it becomes log u would be equal to sin x is the index, log m to the power n. So, that becomes the coefficient. So, it is sin x into log x. Now, differentiate with respect to x. So, log u becomes 1 by u as usual into du by dx. That is equal to, now look at the right hand side. Now, it is in the form of a product, but here both of them are simple functions. So, first function sin x into derivative of log x is 1 by x plus the second function log x into derivative of sin x is cos x. Here we can't do any simplification, only u can be taken to the right hand side. Therefore, du by dx would be equal to, take u, what is u? You write, it is x to the power sin x into, write in the proper order, that's all, sin x divided by x plus log of x into cos of x. Okay. Now, take it as the result 1. So, because the terms that have been given like this particular part is containing only the basic functions like sin x, log x or x here. So, easy for us to do the differentiation. Now, let us move on to the second part of the problem. Now, let v be equal to sin x whole to the power cos x. Again, you have to take the logarithm right here. Take logarithms. Take logarithm. Take logarithm. So, as usual, we will be having log v. Right hand side, see, look here, log of m to the power n. What is n here? N is cos x. So, that cos x or n becomes a coefficient. The index becomes a coefficient. Log m to the power n is n into log m. N means it is cos x into log of the base, that is log of sin x. See, here again we got a composite function. In the first part it was a simple function. Here it is a composite function. So, the differentiation has to be done now. Differentiate with respect to x, 1 by v into dv by dx. 1 by v into log v becomes 1 by v. For v it is dv by dx. Then apply the product rule carefully. See, cos x first function into derivative of the second. What's the second function? Log of sin x. Log of sin x means log of anything is 1 over that function. That is 1 by sin x, isn't it? Log of sin x is 1 by sin x. But sin x itself is a function of x whose derivative is again cos x, isn't it? So, this cos x is the first function. This is the derivative of the second function. So, first function into log of sin x means 1 by sin x. For sin x it is cos x. Next, plus second function. What is the second function? Log of sin x into derivative of cos x is minus sin x. Whenever you have the minus sign, make it a habit to write inside the bracket. If you don't write this bracket, you may write it as log sin x minus sin x. You take it as a different term. It is not so. It is a product. So, whenever you come across a minus sign, and when you are multiplying, always write inside the bracket so that you will not be committing any mistake. Now, it is equal to, now you can take like this. cos x by sin x. What is that equal to? Cot x. Or you can write cos square x by sin x. But I can do some simplification using the basic information. Cos x by sin x equal to cot x. So I write it as cos x into cot x. Then plus of minus minus. I am writing sin x first. Otherwise you may write sin square x here. Minus sin x into log of sin x. Okay. Now this is 1 by v into dv by dx. Therefore, dv by dx would be equal to, take v to the right hand side. What is v? You write sin x whole to the power cos x into, write entire expression. It is cos x into cot x minus sin x into log of sin x. Sin x into log of sin x. Now take this as the result too. The procedure is same for all such problems. The difference is only in the respective functions, that's all. So first one, x to the power sin x, we took it as u. After taking logarithm, we got this one. In this case, this being both of them being simple functions, we got the derivative little bit easily, whereas there we are having one simple function cos x, the other one becomes a composite function for which you have to apply the chain rule, and finally we have arrived at the derivative of the second part of the function also. Now let us go to the original function. What is the original function here? It is y is equal to x power sin x, which we have taken as u, and sin x whole power x. How we had assumed? We had taken that to be equal to v. So you have to write the given function y now is equal to u plus v. Now differentiate. Dy by dx would be equal to du by dx plus dv by dx. Okay. So that is, it has become a simple function. We apply the sum rule here. So u plus v means dy by dx would be du by dx plus, suppose we are having minus, right, minus here, that's all. So it is dv by dx. Now both of them have been calculated. So let me write that one. What is du by dx here? First one I am writing x to the power sin x into sin x by x, sin x by x plus log x into cos x, log x into cos x. Now plus write the second part. It is sin x whole to the power cos x into, write all the terms here, cos x into cot x minus sin x into log of sin x. Okay. Close the bracket and write from 1 and 2. That is why I had given the numbers there. So this is the answer. That is the derivative of both of them. So this is the procedure we adopt to arrive at the result here. So it is, first part is, yes, x power sin x into sin x by x plus log x into cos x. Second one, sin x to the power cos x, the given function, that is v into cos x into cot x minus sin x into log of sin x. So carefully you solve such problems. These are problems are not difficult because the same procedure we are adopting. If there is only one term, that is say y equal to x power sin x or y equal to sin x to the power cos x, there you can directly take the logarithm because there will be only one term. Or if there is a product also, you can take the logarithm because we have a product rule. Or if it is a quotient also, we can take logarithm of a quotient because for product of two functions and quotient of two functions, we have two logarithmic rules. Whereas for sum or difference of two functions, we do not have any logarithmic rule. So directly you can never take the logarithm. So we have to take them individually as u and v. Then finally you have to arrive at the derivatives individually and then combine them. That is, y becomes always u plus v. If minus is there, u minus v, that's all. Then we have already we differentiate them and get the answers ready. Write them together. dy by dx equal to du by dx plus dv by dx. That would be writing all the terms which have been already calculated together. That gives the answer. Don't stop here. See, you have to, after calculation, you have to write y is equal to u plus u, that is very much important. Then you write dy by dx equal to du by dx plus dv by dx, even that has to be written. Usually that carries 1 mark, writing y equal to u plus v and writing the derivative dy by dx plus du by dx plus dv by dx. Usually that 2 steps no, carry 1 mark there. And afterwards, now whatever derivatives you have already calculated, write them in the with that side by side. Then with the proper terms here, then that becomes the derivative of the whole function. Whatever function is being given, the whole function, the derivative would be given. Okay. So this is the procedure we adopt whenever it is given as sum or the difference of the two functions. Or if it is a product or quotient, you apply the logarithmic rule. Otherwise, take the logarithm individually and then find the derivative, write them together in the last step. That gives you the derivative of the whole function that has been given to you. Now this completes the topic on, the problems on logarithmic differentiation. In the next session, I will be teaching you another new type of function. First I give you the definition of that function, then I will tell you how to find the derivative of that function. Thank you.